In pharmacology, the international unit is a unit of measurement for the amount of a substance. The mass or volume that constitutes one international unit varies, based on which substance is being measured, and the variance is based on the biological activity or effect. For the purpose of easier comparison across substances, international units are used to quantify vitamins, hormones, some medications, vaccines, blood products, and similar biologically active substances. The name International Unit has often been capitalized, although major English language dictionaries treat it as a common noun and thus use lowercase. The name has several accepted abbreviations. It is usually abbreviated as U in English, UI in Romance languages, i.e. in several Germanic languages, or as other forms. In order to remove the possibility of having the letter I confused with the digit 1, some hospitals have it as a stated policy to omit the I, that is, to only use U or E when talking and writing about dosages, while other hospitals require the word units to be written out entirely. Many biological agents exist in different forms or preparations. The goal of the U is to be able to compare these, so that different forms or preparations with the same biological effect will contain the same number of IUs. To do so, the WHO Expert Committee on Biological Standardization provides a reference preparation of the agent, arbitrarily sets the number of IUs contained in the preparation, and specifies a biological procedure to compare other preparations of the same agent to the reference preparation. Since the number of IUs contained in a new substance is arbitrarily set, there is no equivalence between new measurements of different biological agents. For instance, 1 U of vitamin E cannot be equated with 1 U of vitamin A in any way, including mass or efficacy. Despite its name, U is not part of the international system of units used in physics and chemistry. The U should not be confused with the enzyme unit, also known as the International Unit of Enzyme Activity and abbreviated as U. Equality and equivalency of U for different substances. To define the U for a substance, an international collaborative study is organized by the WHO Expert Committee on Biological Standardization using various assay systems in several laboratories. The main goal of the study is to reach a consensus regarding methods of analysis and the approach to standardization so that results can be compared. The study is performed using highly purified preparations of the substance, typically in lyophilized form, called International Reference Preparations, or IRPs. Each preparation is divided into precisely weighed samples, with each sample stored in its own ampoule labeled with a code corresponding to the source IRP. Assays are performed using these samples and are calibrated against the previously available U standard. These results can be quite variable. The final U value for samples of a given IRP are determined by consensus. The IRP that provides the best results and shows the best long-term stability is selected to define the next U. This IRP is then referred to as the international standard. Mass equivalence of 1 U. For some substances, the precise mass equivalent of 1 U is later established. If that happens, the former U mass for that substance is officially abandoned in favor of a newly established mass. The unit count will often still remain in use. Vitamin A, 1 U is the biological equivalent of 0.3 micrograms retinol, or of 0.6 micrograms beta-carotene. Vitamin C, 1 U is 50 micrograms L-ascorbic acid. Vitamin D, 1 U is the biological equivalent of 25 nanograms cholecalciferol, ergocalciferol. Vitamin E, 1 U is the biological equivalent of about 0.667 mg d-alpha tocopherol, or of 0.45 mg of d-L-alpha tocopherol acetate. Insulin, 1 U is equivalent to 0.0347 mg of human insulin.